Welcome back to the Data for SaaS series. Today we're going to be talking about backup and restore. My name's Dave Roberts and I'll be your presenter today. So what's on our agenda? Well, first we're going to look at the challenges for doing backup and restore for SaaS providers. Then we'll have a look at restoring a single tenant from shared storage. Then we'll go into a demo and show a few examples with DynamoDB and Postgres. So, what about backups? It's an expectation of any storage architecture. It's also a solved problem. Most storage engines have native tools to do backup and restore. You even have tools like AWS Backup for doing this at scale. So what's the problem for SaaS? Well, the problem is that native tools tend to work at the physical storage layer. We back up the entire file system or database at once. This is okay for silo. But for a pooled resource, this means all of our tenants are backed up together. This is fine if our goal is to restore the entire dataset, but what if we want to restore a single tenant? Unfortunately, native tools usually lack the capability to back up along the lines of our tenant partitioning. Maybe you're using tenant ID as leading keys in a DynamoDB table, or object tagging with S3. The backup tools generally don't have that level of granularity. You're probably going to have to build something yourself, and this will add complexity to your SaaS. And once you've built it, you have to decide whether you want to do this during restore or backup. You're going to be adding complexity into the process, so the common sense answer would be to do this during restore, because we can use our native tools, so we have a simpler backup mechanism. And you can even use managed offerings like AWS Backup to make your life easier. And if we look across the deployment models, we can see that silo is trivial. We back up and restore using native tools. Life is easy. And in the bridge model, where we have a database per tenant, then backup is done at the physical resource level. All the tenants are backed up as one. When we restore to a new database. Depending on the size of the original database, it could be costly to run this, especially if we have a lot of tenants. Serverless instances can be a great compromise between performance and cost here. And so we restore to a new database and have to extract a single tenant. Luckily, most storage engines have native tools to do database or schema dumps, so you can gain a level of efficiency here. And we can also use these same tools to insert the tenant data back into the live dataset, replacing the original database. With a pool model, you're backing up in the same way, but restore gets more complex. So once you restore the entire dataset, you need to scan all the items to see which ones belong to that tenant. This has time and cost associated with it. Then, when you insert back into the live database, you may need to delete the original data first. Deletion and insertion can have a performance impact to other tenants, so you may have to limit how fast you can restore. This can be another compromise. Batch writes can definitely improve your efficiency here. And regardless of whether we separate a restore or backup, we're introducing complexity when working with the bridge and pool deployment models. Generally, we see separation at restore to be a better option because you only introduce complexity during restore. But there are some reasons why you may want to do separation during backup. We still have the same patterns for silo. This doesn't change. And in the bridge and pool models, we can use the same techniques to extract tenant data as we did in the early example. Only now we do it during the backup phase. So each tenant gets their own backup. And when we restore, we use the same technique as before, but the restored database is smaller, so we're slightly more cost efficient. Then we can use those same tools to restore back into the live data set. Now our main benefit here is that each tenant gets their own backup. This can be really useful, especially for compliance or right to be forgotten use cases. It becomes easy to purge individual tenant data, such as during offboarding or complying with data retention policies. Both separation at restore and during backup have their own pros and cons, so you'll need to understand your business requirements to know what's best for your SaaS. There's a practical implementation of separation at backup in the SaaS Operations 2 workshop if you'd like to see this in action. Now, let's look at some examples of performing this approach with common databases. First, we'll look at DynamoDB. In terms of backup options, DynamoDB has two. Point-in-time recovery does continuous backups with per second granularity, and you can define a retention period of up to 35 days. Whereas on-demand backup will take a snapshot of your table, and you'll get a full backup and it will remain until you delete it. In general, point-in-time recovery is a preferred option unless you have data retention requirements which are longer than 35 days. When you restore, you create a new table from the backup. For silo deployments, this isn't a problem. Our application can now connect to the new table. But for pool tables, we need a mechanism to export and import a single tenant's items. And here's an example of how we would do separation during backup. We have a tenant export capability which comprises a lambda to perform the export and a step function to manage the export workflow because it might contain some other steps such as retry. When we call our tenant export capability, the step function invokes our lambda which queries for items belonging to the tenant in batches of 25. We then store this batch of items as a JSON string in S3, prefixed with the tenant ID. And here's the code. We can see that we have standardized input of the tenant that we want to export, the table we want to export from, and the bucket that we will store the export into. And our table query looks for all the items where the partition key equals the tenant ID. We use the limit of 25 items so that we can use the batch write item command during import, and this has a limit of 25 items. And if there are items returned, then we store these inside our S3 bucket. We use previous tokens to handle pagination and continue to iterate until there are no items left. It's not a complicated process, but it will incur a performance impact, compared to native backup, which has no performance impact. And it looks similar in the import process, except now, when our lambda is called, it lists and retrieves all the backed up items belonging to the tenant. Then it inserts these back into our destination table using the batch write item command for efficiency. Looking at the code, we can see that the import is the same as export. Then we list all the backup items belonging to the tenant on the S3 bucket. If there are items, then we retrieve them and batch write them to our table, iterating across all of our items. The code examples here are not complex. However, managing this at scale for many tenants will need mechanisms for reporting and retrying failed jobs. If you'd like to see the code in action, check out the SaaS Operations 2 workshop. And now we want to look at patterns to export and import tenant data using Postgres. We can use native tools for the silo model, so we won't explore these at this time. If we look at the bridge model, then we can use the pgdump command to export a tenant database. Alternatively, we can also use this to export a tenant schema. Then this dump can be saved to low-cost persistent storage like S3. For import, we can use the pgrestore command. Here's an example of restoring a tenant's database, overwriting the original one if it exists. By using pgdump and pgrestore, this is still relatively efficient. But when we look at the pool model, we need to get more granular. One approach is to export the tenant's data to a local file. We're using a where clause to restrict to the tenant in question, and we can then store our backup on cheap persistent storage. When we import back to the original database, we may have to delete any tenant data belonging that's existing already. Then we can copy the restored data back to the live data set. In this session, we looked at the challenges of single tenant backup for SaaS providers. Then we looked at examples to separate tenant data in shared deployment models for DynamoDB and Postgres. To summarize the main points from our session, if we want single tenant restore from a shared storage resource, then we will need to introduce complexity with a separation process. Separation at restore is generally chosen because we can use native tools to manage and perform our backups. Separation at backup gives us backup per tenant, which is useful when managing tenant data during operations like offboarding or migration, or for compliance. I've been Dave Roberts, and I hope you've enjoyed this session. Thank you.